Hello, today we will be explaining the high dive unit. I'm Joseph Lopez.
I'm Angie Gomez.
I'm Rachel Pacheco.
I'm Karina Oriana.
Okay, so in this unit we are assessing a dangerous jump-off Ferris wheel for a circus act. We need to determine where and when a diver falling on a 115 feet tall Ferris wheel should be dropped. So the diver can land in an 8-foot high cart of water traveling by. In this case, our diver is on a Ferris wheel that has a 50-foot radius, a center that is 65 feet off the ground, rotating counterclockwise at a 9 degree per second angle speed, and is on a platform with an assistant to drop them down.
To start, we must know the key functions for our unit problem, such as the angular speed. The angular speed for the Ferris wheel is 9 degrees per second. This is found by dividing 40 seconds by 360 degrees. Since it is the amount of time to make a full rotation on the wheel, the angular speed is incredibly important for this unit since it is found paired with the wheel time in every equation.
Next, we must know the diver's height after t seconds. This equation is a combination of the 50-foot radius, the 9 degree angular speed, and the center 65 feet off the ground. To find the height, we must input the amount of seconds after passing the 3 o'clock positions counterclockwise.
We must also know the amount of time the diver will fall. In this equation, the output F tells us how long it took the diver to fall. First, we must place the input W, which is the wheel time or time the diver is on the wheel. We'll use the equation square root of 50 sine 9 times 12.28 plus 57 divided by 16 because that is the equation to finding the acceleration.
Now that we know where the diver can be, we can discover where the cart will be with this equation. This equation uses the height of where the diver is on the Ferris wheel and subtracts 8 from 65. Since we don't want the diver to go splat, with this we combine it with the formula of an object falling to get the square root cover and the equation to be divided by 16.
We can use the previous equation to find how far away the cart will be from its starting point and the center of the Ferris wheel. Some additions to this equation is that we are multiplying it by 15, since the cart travels 15 feet per second. Also, we are subtracting by 240, since it is the distance between the center of the Ferris wheel and the starting point of the cart.
Now that we can solve the cart's x-coordinate, we can find the diver's x-coordinate with this equation. This tells us how far away will the diver be from the center of the Ferris wheel. It is important to know that a positive number means the diver is to the right and a negative number means the diver is to the left. In addition, U answer will be constrained by the Ferris wheel radius of 50, meaning it must be between negative 50 to 50 feet.
The time we should drop the diver is at 12.3 seconds after the wheel starts turning from the 3 o'clock position. We get this from 15 parentheses W plus square root of 50 sine 9 times W parentheses plus 57 divided by 16 minus 240 is equal to 50 cosine 9 times W.
Okay. The diver will be in the air for 0.64 seconds after being released. To solve this, we need to input the 12.3 seconds into our equation for the amount of time the diver will fall.
The total time the cart needs to travel is 14.83 seconds. This is solved by using the cart travel time formula. The formula contains the height, which is 50 sines open parentheses 9W plus 65 close parentheses, which becomes 50 sine open parentheses 9W plus 57 close parentheses because the cart is above ground level by 8 feet. In addition, the W for 9W is for real time, which is the distance away from the 3 o'clock by seconds.
To start off with the equation, H parenthesis T parenthesis equals 50 sine of 9T parenthesis plus 57. Knowing that the diver is being dropped at 12.3 seconds once it hits at 3 o'clock, which is insert of the time for the equation with H parenthesis of 12.3 seconds parenthesis equals to 50 sine parenthesis of 9 parenthesis 12.3 seconds parentheses plus 57, which 12.3 seconds will equal to 103.83 feet.
The horizontal location of where the diver should land is at 222 feet, 46. The answer is 222.46 feet is because the diver will be falling 17.54 feet to the left of the center, meaning we must subtract 17.54 from 240 since that is the length from the center to the starting point of the cart.
The final location of the cart is at 17.55 feet to the left of the center of the Ferris wheel. This is found by combining the horizontal x-coordinates for the cart and the diver. With this, we found our intersect, which includes the y coordinate of 17.55 feet.
By using these formulas and comparing the steps, we were able to solve to see if the diver will land in the cart.